Time varies. In case of synchronous, main thing is with A, again it has to answer you people. Okay, now we have finished no? So, in case of synchronous bus, what happens? Where you are going to use the common clock. Okay, so for all the device, where you are going to record the same time information. Okay, so depending on clock time, so the operation it may take a single clock cycle to complete its operation, or it may take more than one clock cycle. Depending on the operation, I wrote two instructions. Maybe the first instruction it will take only one clock cycle. The second it may take two clock cycles because it requires to read data from memory. So like that, we have discussed one diagram where it had like more than one clock cycle, multiple clock cycles. So this was an example for multiple clock cycles. Okay, so each operation it may take. So instead of just observe or compare with the previous diagram, what is happening? So here you have more than one clock. So just sending the address and command it may take some clock cycle. Okay, sending data it may take only one clock cycle. So like that, depending on the operation, the number of clock cycle it is going to vary, and accordingly you should be able to write the timing diagram. Any doubt in this diagram? You have to draw the diagram, timing diagram, and can you see here the length of the clock cycle? It should be equal. Okay, it is not going to vary. So next we'll move on to asynchronous bus. Okay, so next we'll move on to asynchronous bus. So what is the important difference between asynchronous and synchronous? So here you are not going to use any clock information to perform the read and write operation. Instead of that, it is going to use a protocol called handshake protocol. Okay, so by sending the signal, it is going to communicate between master and slave. Okay, whenever processor want to request some data, if it is a read operation from the input device, then it is going to send a signal called master ready, and also it will place the address and command information on the respective line. Okay, and it will issue that information over the bus, and whichever the device that matches with the address, that will get recognized, and it will respond to the request that is sent by the master. Okay, so by sending, how it is going to inform to the slave that it is ready to send the data, or it is placed the data on the bus by sending the slave ready signal. Okay, so that means here the communication is taking place with respect to the signal. One is called master ready signal, and the second one we call it as slave ready signal. Okay, when exactly master ready signal is activated? So it is activated to indicate the slave is going to, the master is going to request some operation that should be responded by the slave. Okay, for that it is going to activate the master ready. Once master ready signal is sent, it is going to place the address and command information. I'll just show you in the diagram. Okay, so this is the diagram. You can see here we don't have any clock information. Are you able to see any clock information? No. Okay, so first, what is the first step in asynchronous is, so the master is going to place address and command. So what is address? Indicates to which device it is requesting. Okay, maybe the device ID. If it is memory, it is indicating the memory location. Okay, command. What is command indicates? Is read or write. Okay, and also what size of data it has to read. So the amount of data it has to get from the slave. So that also it is specified in the command. So that information, so can you see here this line indicates address that is passing through the address line. Okay, and light color, that is blue color, light blue color, you can see this line indicates that command. So if you want, you can write it separately also, okay, or you can combine both the signals and send. So that is also okay. You can just represent however you want, but in the textbook they have used this method. So now after placing this, the master is going to send the master ready signal. Okay, can you see here this red color line indicates master ready signal. That means now master is placed a request on the bus. After that, after some time, so whichever the device that recognizes, that means you need to understand that. So whichever the device that are connected here, that match, it will just capture the address that is sent through the address line. Okay, whichever the device it is matching with that address, it will recognize. Okay, it will recognize. So that is me, I need to respond to the request that is sent by the processor. Then what the device is going to do, it will process that command information whatever it is sent. Okay, accordingly the data will be placed onto the bus. Okay, and it will place the data onto the bus, and also at the same time you can just see, so it is informing that slave is ready. So this signal is sent to the, this is control signal. Okay, it is sent through the control line to the processor, indicating, so whatever the data it is requested, it is placed on the data bus. And immediately after some time, so the master is going to capture the data that is present on the data bus. Whatever the data it is available on the data bus, so the master it is going to capture means it is going to read the data and it will be placed into either register or it will be stored into the processor buffer. Okay, for processing or to perform particular task. So this is how the asynchronous bus works. You can just observe, you need to explain with respect to time information. At time t naught, just observe the time information at time t naught, what the master is doing. Master places the address and command information on the bus. Next, at time t1, okay, so after placing, so immediately it will not like activate the signal, master ready signal, it will take some amount of time. Then at time t1, master is going to activate master ready signal to indicate that, so whatever the request that is made, it is available on the bus and that is informed to the slave. Okay, master assert the master ready signal. Master ready signal is asserted at time t1 instead of t0. At the same time it is not doing. It will take some amount of time. Yesterday we have discussed that is propagation of signal information. There will be a delay. Okay, as soon as the information is placed on the bus, it is not going to reach the device. Okay, why? Because why it is not able to reach the whatever the data it is signal or data it is placed on the bus at the same time, because it has to propagate, the signal has to propagate to the device. There will be an interface. Okay, it has to go to interface, then DMA controller if it is there, then it will go to the IO device. So for that it will take some amount of time. Yes, so that amount of time or whatever the time it is going to take to reach the specific device, we call it as propagation delay. Is it clear? So what is this operation? This is input operation. So how you can just change this asynchronous bus for output operation? Yes. Output operation. Input means the master is requesting the data from slave, and whatever the data it is requested, slave is placed the data on the bus and it is sent to the processor or to the master. So how it is going to do for output operation? Yesterday I told for synchronous output operation. What do you mean by output? No, first what do you mean by output? Write operation. Okay. So for write operation, what and all it requires? For write operation, so now processor want to write some data onto the display. What and all it requires? It requires the address, yes, no, and it requires command, and also what data to write? It requires data to send. So now instead of only the address and command, now along with that for write operation it has to send the data, okay, to write it on the output device. Are you getting? So along with this data, you will be getting one more line here. So that indicates the data. Okay. This is called data. This is for output operation. And once it is captured, it will be there. This data will be there on the bus for some minimum amount of time where that particular device should be able to capture and store it to in its buffer. Okay, so that much of time the data should be available on the bus. It should not be just place the data and remove from the bus. No, it requires that data should be stay on the bus for some amount of time so that the particular device it is going to capture that data and store into its buffer. Got the difference? Input and output or read and write. So in the exam you may get either input or output diagram. So now what is the advantage you can find here? The difference between synchronous and asynchronous. What was the major problem with synchronous? Time. What do you mean by time? Very nice. Time clock. Huh? See, in the synchronous bus, we have S, stop. Yes, listen here. In the synchronous bus, what happened? How they'll fix this clock information or time? One clock means how they'll fix the duration, how long it should be. So that is measured in terms of whichever the device that works at slower speed. So that particular speed will be set for the one clock cycle. That means even though if device is working at faster rate, it will be set for slowest speed. So that is one important drawback with respect to synchronous bus. Okay, so that we can overcome using asynchronous bus. There is no issue. If it is between processor and printer, according to that speed, it is going to perform. If it is keyboard, so depending on the speed of the keyboard, the operation is performed. That is in case of synchronous bus. So other than that, what are the major differences? So eliminate the need for synchronization between sender and receiver. Okay, so it does not require any synchronization between sender and receiver. And also in case of synchronous, there is no particular signal sent that is slave is responded to the request that is sent by the master or not. Okay, but in this case, it is going to respond to the request by activating the signal called slave ready. That is one advantage using synchronous bus. So can accommodate varying delay automatically. Are you understanding this meaning? It is going to vary the delay accordingly. That means if it is between a processor, we know that all the devices it is going to work in there according to their speed. But in case of synchronous, what we made, so whatever may be the device that are connected to the bus, which is the slowest speed of the device, so according to that the clock information is set. But in case of synchronous, if it is between processor and printer, okay, so what is the speed? Accordingly, the clock information is going to set. Okay, if it is between processor and keyboard, so it is going to adjust the speed accordingly. So that is one major difference or advantage over the synchronous bus. It can accommodate varying delays automatically using slave ready signal, master ready and slave ready signal. So that is handshake. As soon as the master is sending the signal, the slave is going to respond. Is it clear? So these are the main two advantages of asynchronous bus over the synchronous. So what is the drawback here? I mean disadvantage. So that is data transfer rate with the full handshake is limited to 2 round trip delays. Okay. So this is going to be one more the drawback or limitation of this asynchronous bus. That is every time. So if the data to be transferred between the master and slave. Okay, so round trip means so sending the data, that is the request, and responding to that request, we call it as round trip delay. So there will be once again delay that is acceptable, okay, compared to synchronous bus. So data transfer using synchronous bus involves so only one round trip delay. Okay, so that is a major difference between these two. Yes, take the heading. So that's all about the bus. Okay. Don't scratch your head for whatever the keywords, everything they have given in the textbook, because it is more related to electronics. So just understand the diagram and you should be able to explain how the diagram works. Yes. Now you need to answer what do you mean by interface. Yes. Okay. Very good. So I already told always the IO devices are not connected directly. Voice, yes, last one, last fellow. Yourself, stand up. So what is the function of interface here? Don't laugh, who is laughing for them, I laugh. What is the function? So somebody told the answer is always IO devices are not directly connected to the bus. It requires interface. So now what is the function of this interface? I am not asking something else. I have already explained this part. What and all it contains interface circuit. So before interrupt there was one topic IO access. So now what is the function of this interface we need to discuss. Can somebody tell what is the function of IO interface? For each device, any device you take, there should be an interface. If you know the answer, stand up. Class. Yes. Control.
Control the signals of the devices which need to be accessed.
How it is going to control? Like what are the important ways? If you know the answer, stand up and tell. What are the important components that is present in the interface? Just checking your notes, your written or not. I don't think so. It will be very good. Listen. Observe now. What are the components? I told you to stop your discussion. You are not ready to answer and you are not ready to listen. Yes? Decoder. What is the function of decoder? Decode the address. Whatever the address that comes on the bus, it is going to decode that address and it will try to match with the device address. If it is matching, then that particular device will respond to the request. Next, control. What is the meaning of that? Control signals. Okay, so that is the device is ready or not. So if you go back to the one more topic called basic IO operation, we have discussed two flags. What are those with respect to IO? Do you remember? S in and S out. Okay, so those flag information it will be available in the control circuit. If the device is ready to perform the task, it is going to set the flag bit to 1. Otherwise, it will be 0 if it is not ready. So that information it will be there in the control circuit. Then we have data and status register. What is data? What is that? How it will store the data in the interface? Where it will store the data? What we call those? Registers. What is the name of the register? For input device, for output device. Data in, it is the, either you can use the term register or you can tell that it is a buffer, okay, with respect to input device, and this is the buffer with respect to output device, okay. Okay, just note down. Note down. What are the functions of interface? Hey, who is that man? Last 3 bench, I will send you out. Note down. What are the functions of IO interface? Okay, it can be asked for 2 marks. Explain or write the functions of IO interface. Provides, first one, provides storage buffer for at least one word. Storage buffer for at least one word of data. For at least one word of data. Okay, it will support for buffer storage. Next, second one, contains status flag, contains the status flag, FALAG. So where it is going to store 1 bit information. So contains the status flag that can be accessed by processor, to determine whether buffer is having valid data or not. Whether buffer is having valid data or not. Okay, status flag contains in the status register where the processor will be able to check the device is having the valid data in its buffer or not. Next, third one, contains the address decoding circuit to determine when it is being addressed by the processor. I'll just repeat. Contains the address decoding circuit to determine when it is being addressed by the processor. Next, fourth one. Yes, fourth one, it generates the appropriate timing signals. It generates the appropriate timing signals required by the bus. And also one more important. Shall I repeat? Generates the appropriate timing signals required by the bus. Next, fifth one. Performs format conversion. So this one I have not explained, I will just add it. Performs any format conversion that may be necessary to transfer data between the bus and IO device. It performs any data conversion that may be necessary to transfer data between between the bus and IO device. Okay, so what is the meaning of here conversion? So conversion here indicates that the data can be transferred in 2 modes. Yes, finished. The data can be transferred in 2 methods. One we call it as okay, so the data can be transmitted in 2 ways. One is called parallel mode and the second one we call it as serial mode. So what is the meaning of parallel mode? So where it can send group of bits parallelly, okay, between the bus and IO device. Okay, sometimes the bus if it is supporting parallel method and if device is supporting serial method, example your keyboard, it supports for serial transmission. Then how exactly it is going to accept the serial format to parallel. So for that it requires the converter. Okay, in the input device interface where it will be having the converter where it will convert from serial to parallel mode. Okay, or if it is vice versa also acceptable. So that is from parallel to serial mode it is going to convert the data. What do you mean by parallel and serial? So parallel means, so at a time it is going to send a set of data from D0 to D7. Okay, this is parallel. So serial means it is going to send only one bit at a time, D0, D1 and so on. Okay, that is called as serial transmission. So whenever if bus is supporting something particular format and device is supporting some format, it requires the converter. So where this converter will be available? Where this converter will be available? It will be there in the interface. Okay, one is address decoder, then buffer, okay, that is for storage, then control signals, then status flag. So all this information it will be there in the interface. Okay. So now whenever if the device, whatever the device you take, so it has to be connected to the bus. So how it is going to connect? So for that it requires different types of ports. So that port we call it as parallel port and serial port. Okay, so if I have this device, okay, so now if I want to connect to my device, it requires the port. Can you see there is a port so that I can connect this device? Even this is actually wireless mouse. For this also I need an interface, so that is also connected through the port. So that port can be classified into, once again, parallel port or it is going to be serial. So parallel means, so it is going to transmit the data parallelly. Serial means only one bit at a time. Okay, you should know this. What are ports? Okay, so we'll go with the parallel port. Just take this diagram quickly. Parallel port and serial port we are going to discuss. So just is it the diagram is visible one side? Can you see there are some of the terms we have already used? Okay, so I just explain that process how the parallel port works. This is where we are taking an example of, is it input or output? Check the diagram. Which device we are considering? Okay, what's your name? Input. Why? I've given directly there keyboard switch. Okay, now I'm going to explain what happens when you press a key, how that information will be sent to the processor. See, you just observe so many operations it is taking place when you just press one key from the keyboard. Finished? Hey, I just told you to write, not to discuss. Yourself, get up. Take your book, go outside. Stand up, stand up. Take your book, go outside. What happened? You don't want to go? Huh? Then why you are, what you are doing? Where you are writing? See, this is last warning. Once again, if you repeat, I'll send you out. Finish. Okay, you just keep continue, I'll explain. Test, listen here, stop writing, listen. Stop writing. So now from this diagram you can clearly understand that it is input operation. Okay, so where processor is going to read data from the keyboard. So now how that process works, listen carefully, because you have complex circuit diagram that I am going to leave for you. So this block diagram I am going to explain. So if you understand this block diagram, so the circuit diagram you can easily understand. Okay, last bench, stop writing, listen here. So your keyboard is connected to the bus. Okay. So what happens now? You need to understand that I have pressed a particular key. What happens? It is going to read that key, whatever I have pressed. Okay. And it is going to perform encoding. What do you mean by encoding? It has to convert whatever the character I have pressed to ASCII value. Okay. And that data it is going to store into its buffer, input buffer. So the keyboard, the associated buffer, we call it as data in. Okay, and at the same time, so it is going to send a signal called control circuit, a valid control signal. Okay, indicating that as soon as this control signal is sent to the interface, it indicates that there is a valid data stored in the input buffer called data in, and once valid signal is received, it is going to set the SYN flag to 1, indicating there is a valid data in the input buffer. Okay, after that, what happens? So the data will be sent to the processor. Okay, so now in between, if it is just read operation, I have just started from getting the data from keyboard and stored or sent to the processor. Now, how processor is going to address which device has to send the data? Last two members stand up. Last two members stand up. So now, whenever if the data should be requested from the keyboard, so what and all information the processor should send? Yes. So now processor want to read the data from keyboard. So what and all information it has to send? It has to send the address, okay, to which device it is going to make the request, and also it has to send the control signal called read or write. Okay, and also at the same time it is going to activate or it is going to inform to the particular device that is master ready. Okay, indicating the address and request, that is read or write operation, it is placed on the bus. Okay, once it is received, so immediately the keyboard it is going to identify itself and it will read the data. Okay, whatever the data it is sent, it will be placed onto the buffer, and from buffer the processor is going to read the data. Once the data is read, so immediately this flag should be set to 0. Okay, SYN flags should be set to 0, indicate that there is no valid data. Okay, whenever if you press one more key from the keyboard, it is going to change S into what? 0 or 1? 1, indicating there is a valid data that is stored in the input buffer. Okay, and immediately the processor is going to read the data from buffer and it will process the data. Okay, so that is how parallel port works. So now this is a circuit diagram. So whatever I told, this is block diagram. So now if you go in level depth, okay, what and all the gates are used. So how exactly the signals are sent. So for that you need to write that parallel port input interface diagram. So you need to draw this diagram. So here you need to understand very simple diagram. Okay, so where you can see this we call it as 3-state drivers. Okay, 3-state drivers. Okay, where it is going to get the data from the keyboard and that will be sent to the bus output lines. So how many output lines I have specified here? D0 to D7. And also you can see there is a status flag. Whenever key is pressed, it has to activate the valid signal. Correspondingly, it is going to set the SYN flag to 1. Okay, SYN flag is set to 1. So you can just observe the same information, that is address. It is sent from A1 to A31. That is total number of address bits are 30. Is it 30 or 31 bits? Okay, total 32 bit. In that 1 bit it is used for specifying the what type of operation. Okay, A0 it is going to carry the what type of operation, is it read or write? To indicate that it is going to use the line A0. Understood diagram? Go through, I have written there. Just read out how this circuit diagram works. Any doubt in this diagram? If no, I'll go to the next one. Next, I'll go to the output device. Okay. What is output device here? Printer. So I have considered the output device is printer. So what is the function of that? It is going to print or display that information whatever it is sent by the processor. So that means it is what type of operation? What type of operation it is? Operation. Output means what? Write. Okay, it is write operation. That means now processor want to write some data onto the output device. For that it is going to send three information. One is data, what data to write, and address of the device, and it is going to send the control signal, is it read or write operation. Okay, and also it is going to activate one more signal called master ready, indicating now it is placed all this information on the bus. Okay, once this information comes on the bus, whichever the device that matches with this address, okay, it will recognize itself. If so, here the processor is going to check that particular device is ready or not first. Okay, the control bit of S out, if it is set to 0, indicate that printer is not ready to perform the requested task. Okay, in that case the processor has to wait. In case if processor is, when it is checking the status of the IO device, that is output device, if it is 1 indicate that output device is ready for processing that particular task. Okay, or displaying or printing the data whatever it is sent by the printer. Okay, so it will be keep on checking until unless S out is 1, it cannot send or it cannot place the data onto the data out. Okay, this is the buffer related to output device. If it is 1, immediately it is going to place the data onto the output device buffer, and also it is going to send the slave ready, indicating that output device is ready to accept the data, and it will be displayed or it is printed through the printer. Okay. And once printing is over, what happens? It has to inform to the processor for receiving the next character, okay, or next byte of data. In that case, it has to set the signal called idle. Okay. So if it is idle, indicates that the output device is idle now. So it is ready for accepting the further data. So for that, once again, it has to set S out to 0. S out 0 indicates that. So till as long as the data it is printing, so it cannot accept any further information. Okay, once the printing is over, so it is going to send the idle signal. Immediately it will set the S out flag to 1. Otherwise it will be 0. 0 indicates the output device is not ready for accepting the further request. Okay. So now, similar to the previous diagram, we have one more circuit diagram for output device. It's very similar to that. Only thing is, here it is going to use the handshake protocol for sending idle signal and valid signal. So other than that, remaining all, it is same. So you can just observe what are the major differences. And this one you don't read, just go through that. It is the circuit diagram for combined input and output. Okay, normally they will not ask the circuit diagram. They will ask for input device, IO interface circuit, and also for output device, IO that interface circuit. Okay, so combined you need to learn. Okay. So serial port we'll discuss in the next class.